Cool. All right, so this problem I left off some of the numbers, so I'm going to skip over this one just for time's sake, because I don't have all the numbers. But all it's asking you to do is figure out which one would not fit on there. And like I said, it's missing a few of the numbers, so I don't even know if those would fit on there. And basically, I just forgot to put them on there when I was building it. I just put a few and then didn't put the rest of them on there, so that's on me. So we're going to skip over this first one. The second one says, order these numbers from least to greatest. This was our warm-up question. Do we agree? I don't need to do this one again because we've already done our warm-up. If you followed along with that, you should feel pretty good about it. Here we go. Let's order these numbers from greatest to least. Greatest to least. Now, we have our calculator, so this problem should be pretty straightforward. Not a whole lot going on with that. Let's see if I find my calculator. There it is. So what I want you to do is let's convert all of these to decimals. So if I do this first number, it's going to be 4. How do I find the radical symbol again? Does anybody remember? How about Kate, how do I do it? Yeah. Second, and then you hit x squared is going to create the rational symbol box. Do we agree with that? And then from there, we're going to type in 13. And then what do we need to hit to make it produce the number? Read. Enter. Can anybody tell me what number you got when you did that? Read. 14.422. Now, based off that number, can anybody tell me what type of number that is? Just like if we were going to classify them. Rosie, what do you think? It's an irrational number because notice that decimal doesn't repeat, it just goes on forever and ever and ever. Agreed? All right, what about the next one? Can anybody tell me what 14 2/5 is as a decimal? 14 2/5 as a decimal. Zana, what'd you get? 14.4. 14.4. Now, Ziana said 14.4. I do think there's a benefit, though, to putting these zeros at the end of this number. Does everybody agree with that? Because now I can compare them, and I can clearly see that this number is bigger than this number. Do we agree? 422 is greater than 400. All right, C, 14.33. Do I need to do anything to that one? What should I do, though, just to make this easier to compare? Kendall? Add the 0, right? All right, and so it asked me to order these from greatest to least. So what is the biggest number on here? What is the biggest number? Anthony?
14.422.
So we agree this is the biggest?
Yes.
Okay, what's my second biggest? Read.
14.400.
Very good. And then this is third. They just went in order on that one. Are we good with that? Questions? Okay, moving right along then. All right, here we go. This one says, order these numbers from least to greatest. Least to greatest. Order these numbers from least to greatest. Least to greatest. Least to greatest. Do I need to do anything to Chelsea's number, or is it okay? Do I need to do anything to Devin's number?
Yeah.
I mean, we do, because it's a fraction. Do we have to, we can do it in the calculator, or if you know it, you can just do it. What is 2 divided by 3?
0.6666.
0.66 repeating. Are we okay with that? So if I put a 0.66 here, what do I need to add to this number?
A 0.
Good, 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 good. All right, then we got Wong. How do I do 5/8? How do I do a decimal? How do I do a decimal? Anthony.
You divide it.
5 divided by 8, which gives me 0.625. Uh-oh, well now I'm in a predicament. Well, I need to go back to these other numbers and do. Okay. Yeah, I'm going to add a 0 to this one. Okay, now I'm going to just bring this up. We agree this is a repeating number. I should have put that there. So I need to add a 6 there. Okay? We're good? And then finally, I've got 65%. Mariah, do you remember how to convert a percent to a decimal?
The decimals always at the end of the number, so you take it over 2 times.
Yeah, great job. So now I'm going to have 0.65, and then what can I add after that?
0.
Beautiful, beautiful, beautiful. Okay, so I want to go from least to greatest. What's the smallest number on here? Read. What's the second smallest number, Anthony?
The second smallest number is the
Marcella, good. Good, good, good. Third. What's third? Nathan?
Devin.
Devin. And then the biggest number is Chelsea. Feel pretty good about these? I'm hoping that tomorrow's test goes really well. I'm hoping that it's good. This is our review board again, so just be aware of that. Okay. Order these numbers from greatest to least. Okay, greatest to least. It's nice that it gives us a little bit more specific. So here we go. Now, it does say not drawn to scale. Can anybody tell me what that means by not being drawn to scale? Reed, what do you think?
It's not as big as it seems.
Yeah, and so what it's saying is all those circles are the exact same size, agreed? And since they're all the exact same size, it doesn't want you to get confused and assume that they're all the same size in the picture. It's just using it as a visual representation, okay? So, what I want to do now is we're going to convert all of these. Now, these ones are a little bit more unique, okay? So right here I've got 9 times what? What am I multiplying that 9 by? Read? Yeah, so do you guys remember how to find pi? We did it on one of our examples yesterday. Caden, how do you find it? Yeah, good. So we're going to hit 9 first. Okay, everybody hit 9 first. And then you're going to do second. And then right below the clear button, there's that little arrow head looking thing with the pi symbol above it. Click on that and then hit enter. And then Ruger, will you tell me what you get once you've done that? Invalid. Okay. What'd you do when you put it in there, Ruger?
I put 9 in such squared.
You put 9.
Oh, I got it.
So when I did it, I hit 9 first, Ruger. Then I hit second, arrowhead, and then I hit pi. And so literally it shows 9 pi on my screen. Did that help or no? I think I'm taking a look at it real quick.
Every time I do it, it says
All right, so clear it out and show me what you're doing. Second, and then the arrowhead. No, don't go here, it's second again. And then every time I click it, you're clicking it off.
Oh,
You goober.
so we don't press that.
Nope, that's when you get out of the radical symbol.
Oh.
So Ruger, tell me what you got.
28.274333888.
Is everybody okay with that? 28.274. All right, next one. Now we're going to do the radical symbol. Now, we all remember how to do radical. I know Caden just told us, but does anybody need us to repeat it again for you? Okay, Josh, you're going to hit second. Go down to x squared, and it's going to create your radical symbol for you. And then you're going to put the number 3 underneath it. And then we're going to hit the right arrows. Everybody remember why we hit the right arrow? Because we don't want it to create all of our number underneath there. And then we're going to divide it by 2.
Oh.
Do we agree? Anybody tell me what they got? What'd you get? 0.866. Big difference, right? Big difference in that size of that number. Now, if we were to do it the opposite way and leave it all underneath the radical symbol, when I do that, then I get 1.22. So you see how it does change the numbers. And then this number is already good. Okay, so let me ask you this. Order these numbers from greatest to least. What's the biggest?
9 or 2.
This is number 1, right? Number 2. And number 3. Is everybody okay with that? Okay, let me ask you this. Do we feel okay with ordering numbers?
Yeah.
Can I move on to the other topics of this test? Okay. Let's see, there's another ordering number there. And then we get into scientific notation. Now, scientific notation is what we talked about 2 days ago. Just checking my time. Okay, we're good. It says the mass of a textbook is approximately yada, yada, yada. And it tells me, how is this number written in scientific notation? How is this number written in scientific notation? Well, here's the deal. There's my decimal. I've got to move it, right? Am I going to move it to the right or to the left? To the right. So if I take it, it's going to be 1, 2, 3. Why am I stopping there? Reed, why am I stopping there?
Because you have to have whole numbers after it.
Good. I have to have one number to the left of the decimal. It has to be less than 10. Can we agree with that? Mariah, what am I going to multiply this number by?
10 to the third power.
Times 10 to the 1, 2, 3. But here's my last question. What is Mariah missing? What's the one thing that she's leaving off of this? She's done everything else flawlessly. Ruger, what is it? The negative. And how do I know it needs to be a negative sign? Because it's a super small number. And if it's a super small number, then we have to make sure our negative implies to make it small. Mariah, does that make sense? Okay? All right, next problem. Okay, another scientific notation. Jamie used a microscope to measure the diameter of a hair. She found that the diameter of the hair was 0.00072 meters. How is this number written in scientific notation? Well, I've got to move my decimal, right? Nathan, what am I going to move it in between?
7 and 10.
The 7 and the 2, so it's going to be 1, 2, 3, 4, 5. So it's 7.2 times what? Times 10 to the negative fifth. It's a really small number. Are we all okay with that? Okay? Okay, can I skip this one? Do we feel okay with solving scientific notation? Okay, now, I know these ones are a little bit small to read, but you have access to this on your computer as well, so if you can't see them all. But I want to talk a little bit about these rational numbers and ordering them. So it says, which Venn diagram correctly represents the relationship between rational numbers and irrational numbers? Okay, so here's how I'm going to do this. I'm going to read each one, and you're going to tell me if you agree or disagree. Do we remember what an irrational number is? It's that number that never repeats, it never stops, it goes on forever and ever and ever. We don't find them very often in the real world. So this says, rational numbers and irrational numbers are separate because rational numbers and irrational numbers have no numbers in common. Okay, that sounds good so far. This one says rational numbers and irrational numbers share some numbers because some irrational numbers are also rational numbers. Are any irrational numbers going to be rational numbers?
No.
No, they're not. So this one is an absolute lie. It's lying to your face. This one says that rational numbers go inside irrational numbers because all rational numbers are also irrational numbers. Is that true?
Yes.
All rational numbers are irrational numbers?
Oh, no.
I don't think so. Then this one says all irrational numbers are rational numbers. The correct answer is this top one, and here's why. You remember the ice cream cone assignment that we did?
Yes.
The ice cream cone said real numbers. And then we had the circles, and so it was rational numbers, integers, whole numbers, natural numbers. Where did we put irrational numbers? It was a cherry on top. So if the cherry's on top right here, are there any numbers that are sharing the same circle? No. That cherry or the irrational numbers are outside of the cave. They want nothing to do with us. They're outside of it. Does that make sense? All right, I'm going to stop the video, and I'll keep going on the second one.